Hello everyone, my name is Oscar. I'm a computer science facilitator. My channel helps you to do computer science assessments on various topics which are learned in computer science. Today we are going to do a computer science assessment on a unit which is called data structures and the algorithms. Don't forget to subscribe in order to get more new videos. Share this video with your colleagues, like and give us your comments. So this is assessment number 3, which is also the first assessment on data structures and the algorithms. Let's go right now. The question number 1. What are data structures? What are data types? And give examples for each. So you are going to define what data structure is, and also define what do you understand by the term data type, and you give one example of a data structure and one example of data type. The question number 2, differentiate nonlinear from linear data structures and give examples for each. So as we know, we have two main categories of data structures, which are nonlinear data structures and the linear data structures. So you are going to give the main difference between the two, and you give some examples for each one. The question number 3, what is an array? State the types of arrays and explain the difference between them. So on this question, you are going to give the definition of an array, and you give also different types of arrays, as well as the difference among them. The question number 4, suggests advantages, disadvantages, and the basic operations of arrays. So what are the advantages of arrays? What are disadvantages of arrays? And what are the basic operations which could be performed on arrays? The question number 5 is almost similar to the question number 4, but on this question you give advantages, disadvantages, and the operations on data structures in general. So what are advantages of data structures in general? What are disadvantages of data structures in general? And what are the common operations which can be performed on data structures? The question number 6, what is a two-dimensional array? Give the syntax to declare it in algorithms. So you define what a two-dimensional array is, and the syntax to declare it in algorithms, as well as the syntax to declare a two-dimensional array in C programming, in C++ programming language. The question number 7, here we have different two-dimensional array elements. After looking those array elements, you are going to give the name and the size of this two-dimensional array. How can you declare this two-dimensional array in C++ and initialize this two-dimensional array in C++? So it means that by looking at the following array elements, you can easily identify array name, and you have also the elements of this array, which means that you can initialize this array. So that is what you are going to do right now. The question number 8, which is also the last question. Write an algorithm that allows the user to store two-dimensional array elements and displays those stored elements. Using this algorithm to write C++ program to perform the same task. So on this equation, you are going to write a two-dimensional array algorithm of a program that should help the user to enter different elements of two-dimensional array and prints those into the elements. By using also this algorithm, you are going to transform this algorithm into C++ real codes. So we have a marking guide. The question number 1, a data structure refers to a group of elements with either same or different data types, but the first thing to keep in mind about a data structure is that it is a group of elements, either similar or dissimilar elements, which provides efficient way of storing and organizing data in the computer so that it can be used efficiently. So you know that every computer has a computer memory or storage devices where the elements where data should be stored. So data structures are used to organize data in computer memories or computer storage devices. So data structure refers to a group of elements which are stored under unique name, which should have either similar data types or dissimilar data types. So by the term data structure, we understand how we can store and organize data in a computer memory or computer storage devices. So we have many examples of data structures like arrays. Remember that an array is a data structure where all elements are similar, or just all elements have same data types and are stored into contiguous or attached memory locations. Here you have a linked list. A linked list also is a set of elements where each element points to its previous one. We have also a stack, which is a linear list in which the insertion and the deletion of elements takes place on one part, which is called the top. We have also queue, we have trees, and so on. These are some examples of data structures. So, what do you understand by data types? So, in computer science, we have what we call the variables, or just identifiers, which means the memory location which are able to store different types of data. And in the computer science, remember that data should be the sequence of letters or the sequence of letters or characters, and also numbers of different. We know that we have different types of numbers. We have integers, we have real numbers, and so on. So data type are used to show the types of data that the variables should store, or different operations which can be performed on those variables. For example, integers in computer science means all the numbers without decimal points or binary points. So means positive or negative numbers without the decimal parts. So integers, integer variables are declared by using data type int. And also in computer science we have real numbers, and the term real number in computer science means all the numbers with decimal or binary points, means the decimals, the numbers with, or just the fractional numbers. So they should be with floating data type depending on the number of digit after the dot, and the double. So double data type has size which is greater than floating data type, because double data type is able to allocate many digits after a decimal or a binary point. So we have also characters. We have data type which is called the char, used to declare the variables which are able to store characters, means the letters. And we have also booleans, which is a data type used to declare the variables which are able to store true or false values. Remember that Boolean algebra is a kind of algebra where all variables are able to store only two possible values, either zeros or ones. So you see that we use data types to create or just to define and declare data structures. We can also use, or we simply use data types to declare variables. We use data types to declare functions. We use data types to declare arrays. So data types are used to show the type of data which will be stored by a variable or another data structure. The question number 2, the main difference between linear data structure is that in a linear data structure, all elements are arranged in a linear order. It means that the elements or data are stored in attached memories or contiguous memories. For example, array. An array is a linear data structure because array is a collection of similar elements or collection of elements with similar data types which are also stored in a contiguous memory or in attached memory locations. We have a linked list, which is also a linear data structure or a collection of the nodes stored at no contiguous memory, where each node has a pointer or is pointing to its neighbor. We have also a stack, which is a group of elements with the same data types. which are in which insertion and deletions are allowed only at one end called top. A queue also is a linear data structure. A queue is a linear list in which elements can be inserted only at one end called the real and deleted only at the other end called the front. So, non-linear data structures, on this type of data structures, the elements are not arranged in a sequential structure. It means that the elements are not stored in attached memories or in sequential or in or you cannot access the elements of this structure sequentially. So, for example, a good example on this, we have a tree. Remember that a binary tree, for example, or just for each tree, we have a parent. We have a parent, which is also considered as the root. The root also has many children. So, to access an element of a tree, you can only access a node from a given tree in a hierarchical manner. So trees are data structures with hierarchical relationship among its elements known as the nodes. We can say that a tree is a collection of the nodes where each node, where there is a determined path to pass it through, so that you can access an element of another node. So it's a kind of hierarchical data structure where we have the root and also the children. And you will pass it through. You will pass through the root so that you can also achieve what is stored in its children. So we can use what we call traversal methods to access the elements of a tree, because a tree is not a linear data structure. So its nodes are arranged in a hierarchical manner, where to get the elements of the nodes we have to use traversal methods. Either we can say, for example, so to access the elements of a tree, we have to use traversal methods. So, like in order traversal, or post-order traversal, or pre-order traversal. So the nodes are not arranged in a linear order. We have also the graphs, which are the pictures or the pictorial representation of the set of elements connected by the links known as the edges. The question number 3, it's about the definition of an array, but an array, you understand the set or the group of items, of similar items, which are also stored under the unique name. So array refers to a collection, a set, or a group of elements of the same data types, which are also stored in contiguous memory locations. So it means that the memories locations of an array are attached one to another one. Types of arrays. So by referring on what we call array dimension, we can classify arrays into two main categories. We have one single or monodimensional arrays, and we have also multidimensional arrays. So one single or monodimensional arrays, these are the arrays with only one dimension, and here multi means many, but multidimensional arrays, these are arrays with either 2 or 3 dimensions. So one-dimensional arrays. One-dimensional array is a kind of linear array. As we have said, a linear data structure is a data structure whose elements can be sequentially accessed. And also, an array is a group of similar elements which are stored into contiguous memory locations. So, a one-dimensional array is a linear array. So, the syntax, declaration syntax of one-dimensional array is very simple, but it varies depending on the programming language under consideration. But the general syntax, we have data type. Remember that a data type is a keyword which is used to show the types of data to be stored by a data structure, a variable, a function, and so on. So we have any kind of data type. We have array name, which is a valid identifier. Remember variable naming rules or identifier naming rules. So it will be any name respecting variable naming rules. And we have the size. Each array must have the size, which means the number of elements which should be stored by this array. So syntax to declare an array, you must have data type, array name, you have size. So example of array declaration in C++, we have int a and the size is 10. This means that int is a data type which is used to declare integer variables. A is the array name, and here we have the size or the number of elements which will be accommodated by this array will be equal to 10 integer numbers. Here don't forget to put semicolon, because in C++ each statement is ended by a semicolon. Multidimensional arrays are arrays that have more than one dimension. Means dimension is greater than one. But we have two categories. We have two-dimensional arrays, which are arrays which are like the matrices or the tables. It's any kind of array which has rows and columns, and the data to be stored by these arrays are stored into the cells, which are the intersection of rows and columns. So a two-dimensional array is an array which stores its elements in a tabular form, or these are also the tables or just the matrices. So the syntax to declare this array, we must have always every time data type, because each time we are going to declare a variable, each time we are going to declare any kind of data structure, you must have data type, because this data type shows the types of operations to be performed on the data structure, and also the kind or the types of elements to be stored by this data structure, remembering that a data structure refers to the group of dissimilar or dissimilar elements depending on the type of data structure under consideration. So we have data type, we have array name, we have row size. Row size means the number of rows for this array, and we have also column size, which picks the number of columns of this table. So example of declaration of a two-dimensional array in C++ is this one. We have int, which is data type. We have a double arrow, which is the name of this array. And this array has 5 rows and also 5 columns. Three-dimensional arrays are a collection of two-dimensional arrays. So the syntax to declare is almost the same as the syntax to declare mono or two-dimensional arrays. We have data type, we have array name, we have size 1, we have size 2, we have size 3. Remember that three-dimensional arrays are the collection of two-dimensional arrays. So what are the advantages of arrays? Why the programmers need arrays in their programming, or while they are creating programs? So arrays are advantageous in different ways. For example, it is very easy to access an array element at any location, because arrays have indices. So each memory location has its corresponding index, which can be used to access easily an array element in a specific location. So also to search an element from an array. So in computer science, there are searching methods, which should be binary search, linear search. So it is very easy to apply searching process on arrays, because an array is a collection of elements of similar data types, and also an array has a finite number of elements. So to search, to apply the searching methods on arrays, the searching methods are applied easily compared to other data structures. Two-dimensional arrays are used to represent matrices. So a matrix means a set of rows and columns. So in computer science, we can use a two-dimensional array to represent a matrix, which is a term commonly known in mathematics. So also another advantage of array is that an array is able to store many similar elements, or many elements of same data types. So also we can apply sorting methods like selection sort, bubble sort, and so on to sort the array elements easily. So we can sort array elements by using various sorting techniques in either ascending or descending order without many difficulties. So, but there are some disadvantages of limitations of using arrays. For example, the size of an array is fixed. Once you declare an array and specify its size, array should not store the number of elements which is greater than its size. So you must store the finite number or finite number of elements into any array. And also allocating less memory than required to an array leads to the loss of data. This means that once you have created an array, so during initialization, you have to store the elements whose memory is equal to the size of declared array. So allocating this memory to the required to an array leads to the loss of data. A single array cannot store values of different data types. So arrays are only used to store similar elements or elements with same data types. It means that you will create arrays of characters, you will create arrays of integers. You cannot create or define an array which is able to store, for example, integers and floating point numbers. The deletion and insertion operation in arrays are very difficult to implement as they store data in contiguous memory locations. So we have also basic operations supported by arrays like traverse. Traverse an array means print all array elements one by one. So remember that to access array elements, we must use indices. So as we have the size of an array, indices vary from 0 to size -1. So we can traverse or we can print array elements one by one. We can also add new elements in a given array at a given index. So after declaring an array, we can store its elements in different memory locations. We can delete an element at a given index. We can search an element using any searching methods. We can search for a particular element at a particular memory location of an array. We can update an element at a given index, means we can change the element. We can change an element and be replaced by a new one. The question number 5 is about the advantages of data structures in general. So data structures, either arrays, queues, stacks, are used to store information on hard disks. Remember that by definition, data structures are the methods which are used to organize, to store and access different types of elements which are stored also on various computer storage devices. So data structures allow storing information on hard disks. Abstract data structures like queues, linked list, make the programs more efficient. Data structures are necessary for designing efficient algorithms. Data structures provide reusability and abstraction. Using appropriate data structures can help programmer save a good amount of time. So a program. So a programmer can use different data structures to reduce the number of statements of a given program, and also which will reduce the time for compilation. So this means that these data structures help programmers to save good amount of time while writing down the codes, while the compilers are compiling and running the programs, and performing also operations such as storage, retrieval, or processing of data. Manipulation of large amount of data is easier. Disadvantages of data structures. So data structures also have some few disadvantages, like application of using data structures require high qualified professional resources to manage the operations related to data structure. This means that data structure skills and knowledge, data structures skills are not for anyone. So to develop a program containing data structures require skills in using data structure. It means that it is difficult for some programmers, or it is difficult for the beginners to create computer programs by using data structures, because to use data structures in specific programs require qualification or just professional resources to manage operations related to data structures. When we say professional resources, means enough memory, computer memory, and so on. Amount of processor or just processor speed. So an application using data structures requires highly qualified professional resources to manage the operations related to data structure. Bigger the application or data structure involved in creating and maintaining application, more is the requirement of manpower. This can increase maintaining data structure costs. So once you wanted to develop a large computer program able to run different data structures, this will cost so much money, because bigger applications or bigger programs containing data structures require programmers with qualified programmers, or just the programmers having knowledge and skills to deal with data structures, and also the computers to run the following programs must have big memories and also processors to run such kind of programs. So in a few words, we can say that data structures in application requires so much money, or requires high costs. Designing your own data structure may involve complex algorithms and may require a lot of time and testing to conclude they are foolproof and ready to use for organization purpose. So you have to take so much time to test your programs to see if the programs fulfill or just solve the problems of the society, or the problems of the world. So we have some common operations which can be performed on data structures, like searching. So for any data structure, because a data structure is a collection of many elements, either with same or different data types, so we can search for any data from a given data structure. For example, if we have a list, we can search for an element, a particular element from a list. If we have a queue, we can search for an element of a queue. If we have an array, we can search for any element of an array from a particular array location. So searching. So we can search an element from any data structure by having a binary tree. We can search for a particular element in a given node, for example. Sorting means arranging elements in a given order. So we can sort elements from A to Z. The order means starting from A to Z English alphabet and Z to A order, or simply we can arrange elements in ascending or increasing or descending order. Ascending order means from smallest to the greatest. Descending order means from greatest to the smallest. So we can sort the elements of a given data structure. We can sort the elements of a queue. We can sort the elements of an array. We can sort the elements of a list. We can sort the elements of any kind data structure without difficulties. Insertion means the action of adding new elements on a given data structure. For example, on queues, we can add new elements because a queue has two parts. There is a part where the deletions are made, which is called the front, and another part where the insertion, and we can add new elements of the queue. This is what we call Rio. So by having a queue, we can increase the number of elements for that queue. So insertion. Deletion means reduction or removal of existing elements of a given data structure. We can also update the data structure. For example, once we have a list, we can update it. So the question number 6, a two-dimensional array is a data structure that contains a collection of cells laid out in two-dimensional grid, similar to a table. As I have said, a two-dimensional array is like a table. A matrix has the specific number of rows and the specific number of columns, and the data are stored within the table cells, because intersection of each row and the column forms what we call a cell. So we can declare a two-dimensional array by this way. So we use keyword set, array name, assignment operator, we have keyword array, we have row size, we have column size of data type. So this is the definition of two-dimensional array and the declaration of a two-dimensional array in algorithms. So these are pseudocodes. These are not real codes, means these are not the codes of any given programming languages. So this is how we can declare a two-dimensional array in algorithms, or the pseudocodes, or the unreal codes which are used to declare a two-dimensional array. For example, we have set age, which is equal to an array of 2 rows and 3 columns able to store integer numbers. So data type, array name. So this is how we can declare two-dimensional array in C++. This is the C++ declaration of any two-dimensional array with a given number of rows and a given number of columns. Don't forget to write down the semicolon, because in C++ program rules, each statement is ended by semicolon. So float is data type, mark is array name, this is the size, the row size, or just the number of rows. This is the column size, also the number of columns. So the question number 6, by looking at its elements, we can say that array name is A, because we have, by following the syntax to declare an array, we have data type, we have array name, we have row size, and also we have column size. And as I have told you, we can access a particular value of an array by using index, row index, and column indices. So, and as I have told you, we access array elements starting from 0 index to size -1. So we have a particular an element at row 0 and column 0, which is 18. So array name is A, and also the size is equal to 12. We can count the number of these elements on, and also by looking at the rows, you see that the row size is 3, because we access we can access the elements on these rows starting from 0 to 2. Which is 0 to size -1. So it means that row size is 3 and the column size, row size is 3 and the column size is also 4. So the size is calculated by taking 3 times 4, which is equal to 12. Or just you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the size of this array is 12. So this is the C++ declaration of this array. We have int, which is data type. We have the name of this array, because array name is A. We have also row size, which is 3, embedded also in braces, and also column size, which is 4. Here we have also semicolon. So initialization, we write down declaration. We first of all declare an array. We use assignment operators, because a two-dimensional array is a table, and each table has the specific number of rows. So you see that here we have 0 at the columns. The column size is 0. Here also 0. Here also we have 0. Here we have 1. So it means that this is the first row. So an element at row 0, column 0, row 0, column 1, row 0, column 2, row 0, column 3. So this is the first row. Because we have 18, 16, we have 14, we have 19. 18, 16, 14, 19, and so on. Or just we can remove inner curly brackets, because they are optional, and write down every element of this array. So here we have the question number 8 is about to write down an algorithm which can help the user to store a two-dimensional array elements of any size and print or display the elements which have been inserted. So we use the start, the keyword start, when we are going to write down a computer algorithm. So we declare an array. In the algorithms, set array name equal an array. We specify, we take a two-dimensional array of any size here, and we are going to declare the variables, integer variables, which are like indices, which will help us to enter or just to store the two-dimensional array in different locations of this array, as well as which will be also used to display all elements which have been stored within the particular memories of this array. So write function into two-dimensional array elements, and we use inner for loop. So for row which is started by 0, index to the size, row size -1, do. This is for row on the same column, also on the column starting by 0 to the size of column -1. So input the array, a two-dimensional array elements. So I is incremented, or the size of row size is incremented by 1, or for each iteration the new value of row is equal to the old value of row plus 1, because array elements are attached. So we start by 0 to size -1. And also these statements are used to retrieve what is stored into array. So write the stored two-dimensional array elements are, we use inner for loop starting for the rows and the columns. So for I, which is equal to 0 to I -1, do on the same row use also the column starting by 0 to the row column size -1. So display what has been stored into that particular location. Row sizes are incremented, as well as column sizes are incremented. We close for loop by using end for here, end for to close the outer for, and the end for to close this inner for loop. So by using the given the given algorithms, we can also transform it into real codes. For example, I have used dev C++ to write down a computer program, C++ program. So as usual, we have preprocessor directive, we have include the IOStream, and using namespace std as usual. Here you know that each C++ program must have main functions. Here we have int main with its arguments, and the first thing to do is to declare an array. So you know that to declare an array you need to have data type, array name, and you have, because this one is a two-dimensional array, you have row size, means the number of rows as well as the number of columns. But this array also is declared together with other two variables, variable I and variable j, which are used to access the locations of an array where the elements, a two-dimensional array elements will be stored, and also where two-dimensional array elements will be displayed. So we have cout function. It's a function which is, it's a C++ function which is used which is used once you want to print something. It's like a printing function in algorithms. So this is replaced by write, print, display in the algorithm. So enter a two-dimensional array element. We want it to inform a computer user that he or she is going to store the elements into different two-dimensional array locations. So we use a inner for loop. We use a nested for loop as usual. We have outer for loop and also inner for loop. So the rows start by 0, and you see that the size is 3. Remember that the position of last memory location on rows is size -1. So I for I, which is assigned 0, semicolon, I which is less than 3, means I is allowed to take values from 0, 1, 2, I which is incremented. So here we have the body of the loop. We have also another for loop. This is used to, so because we have to consider row and column. So this variable j, this represents column sizes. So for a column which is assigned 0, means the first column, and also columns are less than 4, each column is incremented by 1, we have to store a particular array element. For example, I is assigned 0, 0 is less than 3, the condition is true. Now what is the following? We have to enter the value at row 0, and also incremented by 1. Insert a new value at column which is equal to 1, incrementation also, and store another element at a column whose index is 2, and incremented by 1, and store the last element at a column whose index is 3, and also increment this variable which is tested in outer for loop. So after storing all elements into a two-dimensional array, we have also to print what we have stored. So you see that here we have cout function, and also stored two-dimensional array elements are. So we use also nested for loop, as we are going to display array elements by using the same methods that we have used to store such or those elements. So we have outer for loop, the variable or just the row size is 0, 0 is less than 3, the condition is true. Now the statement must be executed, and the statements of outer for loop is also another for loop. For column which is equal to 0, we have to print the element already stored into this location, and also column size is incremented by 1, it is 1. 1 is less than 4, the condition is true. The element at A01 is also printed out. Here also column size is incremented by 1. In this case, we have to. Here the element at 0 row and 2 column is printed out. Column size is incremented by 1, it is 3. 3 is less than 4. So the element at row 0 and 3 column size 3 is printed out. This variable is incremented by 1 is 4. 4 is not less than 4. The condition is false. In this case, inner for loop stops, and immediately the variable in outer for loop is incremented by 1. It becomes 2. So the process continues till all elements will be printed out. So after writing down C++ program, we can compile and run it. So this shows that our computer program is running without difficulties. So we can, there is output. So this table is used to show output. So you see that enter a two-dimensional array elements. This phrase has been copied here because cout is used to print what is embedded within double quotes. So, and also we are going to enter array elements in different locations. We start by 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13. Once we reach array size, you see that array size is 3 times 4, which is equal to 12. So we have 12 elements. Immediately the computer, immediately the program shows you the stored elements. So you see that we have also this cout function prints or just copies this phrase. The stored two-dimensional array elements are, you have the same sentence, and you have all enter the elements. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13. So you see that our computer program is running, and this computer program gives us the needed output. So thank you for watching my video. I hope that you have got knowledge and skills about data structures. Today we have focused on data structures, but next computer assessment also will talk about other different types of data structures, like abstract data structures, and also some how we can apply the method to access the elements of different data structures. So thank you very much for your attention. I hope you enjoy my video. Don't forget to subscribe in order to get more new videos, and share this video to your colleagues, and also like and give us your own comment. See you next time.